In this one, we're gonna go over a couple of log properties, and then we'll use those log properties to find the answer to a handful of logarithms. I try to give you just a silly story to help you remember it, but then I'm gonna give you the mathematical reason why. If you use your imagination here, I have one log. So if I have this lumberjack, he has one log that he's carrying. Well, if he has a log, that means he chopped down a tree. So one log means no trees. Just follow the logic. Okay, so then, like, what the heck's that about? Well, log base 7 of 1. If I have one log, log of 1, I have no trees. The answer is 0. It does not matter what the base is. So log base 2 of 1, a log of 1, I get 0. This one here, I don't have a base number sitting here, but we know that anytime it's indivisible, that's base 10. So log base 10 of 1, well, that equals 0. Or maybe I have a natural log, base e, but a log of 1 is equal to 0. So when you have one log of 1 log, you get 0. Okay, now the reason that that actually happens, I've got a logarithm no matter what the base. If we change to exponential form, remember this b right here tunnels under. So then the log falls in, so I have 1 equals b to the power of 0. And if you have 1 equals b to the power of 0, no matter what number to the power of 0 equals 1. That's why no matter what the base numbers are, logarithms, the answers to logs are exponents, so the exponent has to be 0. Okay, but big takeaway is you take a log of the number 1, no matter what the base is, the answer is 0. Okay, then the next property, I've got this guy's head's disappeared. When you have matching bases, everything kind of disappears. So in this one, the little tiny number here is called a base. Now if I focus only on the blue and the purple, that's a power. That's a base and that's an exponent. So we have a base and we have a base. When these bases match, all of that goes away and the answer is the exponent. Then this one here, here's my base number. All of this is in the exponent, but that's a base and that's a base. So when the bases match, we get just that guy right there. Okay, so then let's put that in action. Let's say I want to use this property, log base 5, 1/5. To use the property, I know that if I'm going to have a matching base, if this is already base 5, I need this to be base 5. So that is going to have to be a 5. So what would 1/5 be if I rewrote it as 5? What exponent would you have? 5 to the what is 1/5? Just remember how you have a negative exponent. So this is 5 to the power of -1 is 1/5. These are equal to each other. Since I have matching bases, the answer is -1. Okay, so this one here, log base 2, I've got to keep this base, but I've got to rewrite the number 32 as 2 to the power of something. So 2 to what is equal to 32? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's 2 to the 5th power. Now that the bases match, my answer is 5. Okay, so let's do another one. This guy here, log of 100. We don't see it, but what's the base when it's invisible? It's got 10, okay? So if I'm gonna use this property, I need the bases to match. So this is going to be base 10 still, but 100 is 10 to the second. And since these bases match, the answer is 2. Okay, so let's look at another one here. Log base 8 of 1 over 64. So I'm gonna have to keep base 8. So how can you rewrite the number 1 over 64 as 8 to the power of something? Well, 64 is 8 squared. So if you have 1 over 8 squared, if I want to move that to the top, it's going to be 8 to the negative 2. 8 to the negative 2 is 1 over 8 squared, and 1 over 8 squared is 1 over 64. So now that those bases match, the answer is negative 2. Okay, so one more. I'm going to have to stick with 3. So how can I rewrite 27 as 3 to some power? Well, 3 times 3 is 9, and 9 times 3 is 27. So that's 3 to the third. So having 3 to the third is 27. Those match, so that's my answer.